Well, hello once again. This is KP the Math G, and I appreciate everyone who is tuning in. I appreciate you very much. We are talking about this time. We're talking about a little bit about a particle. Okay, particle motion. We're talking about a little bit about velocity, and this is a velocity equation, well actually a graph here, and we're going to answer a few questions about this velocity equation. This is a 2008 question. This is a free response question number 4. Okay, if you wanted to, you could Google that and you could get this, you could pull up this problem. I don't have every last word up here, but I do have all the pertinent information that we need. Okay, a particle moves along the x-axis in a straight line. Okay, on the closed interval from 0 to 6 is under consideration here. All right. T is between 0 and 6, including 0 and 6. Differentiable, which means that it is continuous. That's important. We know that piece of information. V of t is equal to 0 at x equals 0, 3, and 5. That's obvious from the graph where it crosses, okay, 3 times. Let me put my 0 up here. Alright, right there. We have horizontal tangents. I know this is not drawn to scale, and it should have been. I should have moved this over a little bit at t equals 1. I guess I could fix that just a little bit and make that look a little bit more like it is. Alright, horizontal tangents here. So we could go right there and then come up. Horizontal tangent at t equals 4. Okay, put a point right up here somewhere. Alright, right there. Looks good. Okay, now that probably looks a little more like what it's asking for right here. Alright, so there it is. Okay, there's areas on the closed interval between 0 and 3. This area is 8. But actually, when you think about it, since v of t is less than 0 on this interval, we really want to say it's negative 8. Got it? We understand that? Okay. And then same, let's see, from 3 to 5, on the interval from 3 to 5, this area up here, this region is 3 units, whatever that is. Okay, and then this over here represents 2, but we want to make it negative 2. Alright, and they don't say that. They don't put the negative and positive signs. We have to know that because of the nature of the graph. Anything below the t-axis is negative, and anything above the t-axis is positive. And we have to keep that under consideration, close consideration. Now, part A says, and this, by the way, is the graph of V. And remember, when you find the area, you're finding out where is the particle at this point, okay? You are looking for position. Okay, this area is dealing with the position and where the particle is at any given time t. Alright, in this particular case, for this closed interval from 0 to 6, find both time and position of the particle when the particle is furthest to the left. And that is the key here, furthest to the left. Alright, so let's think about this. Alright, so from we see that V at T, I'm just gonna have to put something up here. Let's get a different color, because I have my graph in that color. Let's see, I'll use red again. Alright, here we go. V at T is less than 0 on the intervals. Let's just say on the intervals, since I've got a little bit of room, very little room. Intervals. Let's just, I'm sorry, I apologize. Alright. Bulls. Okay, I will finally get this. Alright, on intervals from 0 to 3 and from 5, okay, also from 5 to 6, where T is between 5 and 6. Alright, V at T is less than 0. It's negative. Okay, V at T. And since we, oh, by the way, before we go any further, at T equals 0, the particle is already at T equals, and that's not 2. That is not 2, but that is a negative 2. Alright, and I believe I got that right. Yeah. X is at negative 2. Alright, so let's take a look at this now. We know that we're not really concerned about that part that's greater than, but V at T is. We're really concerned about these values here on the interval from 0 to 3 and actually from 0 to 6. It's actually given to be X at 3 and X at 6. Those are the two, and actually when we say X at 3, we're saying from 0 to 3, and then here at X at 6 is from 0 to 6. Alright, so just keep that in mind when you see that right there. Alright, so let's look, because here this is above, we're not worried about from 3 to 5. Alright, so this is above, and we just have to keep that in mind. Okay, so let me flip this over. Just kind of remember, from 0 to 3 is negative 8, from 3 to 5 is 3, and from 5 to 6 is negative 2. We may have to flip back and forth pretty frequently since we're really out of space here. Okay, so let's go ahead. Alright, so from 0 to negative 3, or from 0 to 3, this area is negative 8. From 3 to 5, here is 3, and then negative 2 here. Okay, so let's keep that in mind. Now, we're looking at X at 3. Let's look at that. Alright, so let's consider X at 3. X at 3. X just represents the position equation, function or whatever. X at 3. Alright. So let me look at that. Now that is, remember, we're going to start at negative 2. We are going to go from 0 to 3. Let's see, V at T dt. V at T dt. Alright, now remember, when you take the definite integral of V at T dt, you're getting a distance. Okay, we're getting distance. That's what we're talking about, or probably in this case position. Alright, so we know that negative 2. We know that that was negative 8. Remember a while ago. Alright, so this is, we already have an initial condition for this to be at x is negative 2, and then we're going to add negative 8 to that from 0 to 3. See that? It's as simple as that. Okay, just keep that in mind. I'm going to flip this back over. And we have an answer of negative 10. Alright, x at 6. Now we're looking at the interval from, we're still going to start at negative 2, but we're looking at the interval all the way from 0 to 6. Alright, so we know this is b at t dt. We know this is negative 2, okay, plus. Alright, we know that from 0 to 3, that was negative 8. Alright, now from 3 to 5, that's 3. And from 5 to 6, that's negative 2. So we have to add all of that up. Negative 2, negative 8, plus 3, negative 2. Alright, right here. Alright, so plus 3, and we got to go all the way through. We got to count this also. Alright, we're going all the way from 0 to 6, so we've got to add it all up. Alright, so negative 2 plus negative 8 is negative 10. Negative 10 plus 3 is negative 7, and then negative 7 plus negative 2 is negative 9. We could do x at 5 if you wanted to, x at 5, but now we can do that, but that's equal to, now we already know it's negative 2 plus negative 8. Alright, if we do that, 0 to 5, you already start at negative 2. You got to add the negative 8, and then just add the 3 there. But you're going to see that that's why you don't really need this one. This is 10 plus negative 10 plus 3, which is negative 7. Well, okay. Actually, it's, if we wanted to do this correctly and do it the proper way, x at 5 is equal to negative 2 plus that interval from 0 to 5, v at t dt. Alright, now you have to consider all of it. That's negative 7. So the greatest one, the furthest left, is the one with the greatest negative number. This one is furthest left. Alright, so furthest left, okay, on the interval, or at x at 3, if you want to say that, which is equal to negative 10. Alright, that's the A part that we're looking for. Okay, that's the A part. I'm going to erase this because I do want to at least do part B. I don't believe I want to deal with C and D, but this one here, part B, may take up a little bit of time. So I could just stop the video here, but I think I am going to go with B as well. Okay. Okay, bear with me here. I do apologize for taking up so much time just to erase. Now, all right, I'm almost there. Again, thank you for your patience. I have to say that pretty often, don't I? Okay, all right. I think that's enough for what we need to do. Okay. Now, on this problem here, the question is, how many values of t, alright, how many values of t let me make sure I'm asking that question. Yeah, okay. Of t where t is between 0 and 6. Okay, alright. Is the particle at x equals -8? How many times? How many values of t? Alright, now let me introduce you to something that we have not really talked a whole lot about, if anything. Have you heard about, you've seen this expression called IVT? It's a theorem, isn't it? It's an intermediate value theorem. Okay, there's a mean value theorem, and there's an extreme value theorem, and then there's an intermediate value theorem. Okay, which simply means that if you have something, alright, like for example, I say we're looking for 5, and we know that this is continuous, alright, and here is what, 1, and this is 6, and the particle is definitely on this interval. It's on that interval. It's going to be continually going this way, or from 6 back to 1 back this way. You are eventually going to go through 5, aren't you? Okay, that is what we're talking about here. Alright, does that make sense? I hope it does. Alright. Alright, so that's really a real brief that's a real brief illustration. I get that, but that's probably about as good a illustration as I can come up with. Maybe one of you have a better one, but I feel like that's a good one. And it's in between, in the middle somewhere. It's not that this graph is broken or anything like that. It is differentiable, which means that it is continuous, and that is important that you understand that. Okay, now let's talk about that just for a little bit. Okay. Let's look at our, now you're going to use -2 on this first one. Now we're actually looking at from, I want to say from 0 to 3, I want to say maybe from 3 to 5, and then from, well, actually from 0 to 5, and then from 0 to 6, whatever, something like that. Okay. Alright, let's kind of look at this. I wish now I have not erased that. I erased some really good stuff just a while ago, but that's okay. Let's go back over here. Now our initial place, our initial beginning at t equals 0, x is equal to -2. Alright, so let's consider, we've already looked at some of this already, but we know that, alright, so in other words, let me see, we see that, alright, here's one of them, not v, but x at 0, x at 0 equals -2, and then of course x at 3, remember we found that to be -10. Okay, And so if we see that that is going on where we have negative 2 and 10, is negative 8 between negative 2 and negative 10? Yes. Okay. That's what we're talking about by the intermediate value theorem. Okay. All right. Let's look at another place. I think there is another one. Let's see. Let's continue from x at 3. All right, x at 3 is negative 10. And we'll say we're looking at x at, let's see, yeah, x at 5. Yeah, x at 5. We found that to be negative 7, because remember that is negative 2 plus negative 8 plus 3, which is negative 7. And sometimes you might want to, we've already looked at this from the last problem. This was negative 2 plus negative 8, which is negative 10. Alright, and so on, like that. Always start at x at 0. Alright, go to your first point right here, 0 to 3. And then from 3 to 5. And then guess where we're going here. Now, again, is negative 8 between negative 10 and negative 7? And that answer is yes. Alright, that fits. And you have to remember that because this function is differentiable, that means that this is continuous. Okay, all right, it's continuous. It's continuous here and it's continuous here. So eventually you are going to run into negative 8. All right, here. All right, and then the third time we're checking from x at 5 to, okay, x at 5 is equal, and we'll just say, instead of and, we'll say 2. Alright, x at 5 is equal to negative 7 to x at 6, which is, let's see, that turned out to be, let's see, I'm trying to think what that was, negative 9, yes. Alright, negative 9. Now remember, this one is just like this, plus the interval from 0 to 6, d at t dt. Now if you want to show that, you may, but that's equal to negative 2 plus negative 8 plus 3 plus, I want to say negative 2, right? And so these two are negative 10. Let's see, negative 10, negative 7, and then negative 7 plus negative 2 is negative 9. Okay, so that is, yeah, right there. So is 8 between, yeah, so 8 is between those right there. And here's how you answer this. Okay, negative 8. I say 8, but I mean x equals negative 8 would run through here, and here, and here. Alright, so by IVT, trying to see exactly how they say it. Intermediate value theorem, there are 3 values. Or 3 values of t where x equals negative 8. Alright, and that's you know, you may have to kind of show a little bit here. I believe you can get away with this. I don't know if just saying yes is good enough, but you can say x equals 8 is between x at 0 and x at 3. And you could say that. Okay, so x equals 8, negative 8 rather, is between, and we could even say x at 0 and x at 3 and x at 3 and x at 5 and x at 5 and x at 6. Okay, so not just saying yes yes 3 times. Okay, that's really, this is probably much more complete right there. Alright, is between those. Alright, and so 3 times, and you have to say how many times it occurred. Alright, intermediate value theorem. And I thought maybe that would be a good thing to look at. And again, the question is, for how many values of t, where t is between and including 0 and 6, is the particle at x equals negative 8. And that's what you want to do when you start at 0 and you go to the first number. So, once again, 0 to 3, 0, that's at negative 2 already. Negative 2 plus 8 is negative 10. So yes, somewhere between 0, t equals 0, and t equals 3, x is equal to negative 8 somewhere. I don't know exactly where, but somewhere between those, on that interval, alright, where t is between 0 and 3, is x is equal to negative 8. Alright, and also from 0 to 5, somewhere on that interval, somewhere, because, as we just pointed out, x at 3 is negative 10, x at 5 is negative 7. Alright, so actually from 0 to 3, and then from 3 to 5, we get that, don't we? Negative 8 plus 3 is negative 5, but you got negative 2 more, so that's negative 7. Okay, so we do have something there. Okay, negative is between negative 10 and negative 7. Okay, so yes, you have it there. And also all the way, negative 2 plus negative 8 plus 3 plus negative 2 is negative 9. But you're going from x at 5 to x at 6. X at 5, we just found that to be negative 7. Negative 7 to negative 9. Somewhere in that interval, okay, we are going to cross through x equals negative 8. The particle will be at x equals negative 8 3 times because of the intermediate value theorem. Okay, alright. So we already dealt with something that's furthest to the left. We could have talked about something furthest to the right. Alright, x at 5 would be furthest to the right. That would be negative 7. This one here, x at 3 was negative 10. X at 6 was negative 9. Very close here. Alright, be furthest to the right at x at 5, but furthest to the left, x at 3. And remember, when we say x at 3, we're talking about the interval from 0 to 3, beginning at negative 2. Keep that in mind always. Alright, let me pick this up. It usually sticks. Oh, it sticks this time. How about that? Okay, and that usually just slides on down. But anyway, alright, I hope this has helped you out. I wanted to really talk about that. I was confused about it for a while, and I had to really go over it with some who have done this before, other teachers, other professors who have done this before me, and kind of showed me my first and second and even my third year how to do this a little bit. Think about what's going on here, and so just kind of keep those kind of things in mind. All right, well, anyway, that's all we're going to do for this time. There are two other parts, C and D. We can talk about those, but we're not going to get into that. It would be very quickly, though, but I just don't want to get into that. Well, I guess we could. On the interval, we're just going to just look at it briefly. Where t is between 2 and 3, right here, is what's the question here? Is the speed of the particle increasing or decreasing? Well, we know that from 2 to 3, we know that v at 3 is actually equal to 0. And it's faster this way, so it's slowing down just by looking at the graph. The speed is decreasing. But there's another thing you can look at also. V at t on this interval is less than 0. And v prime at t, which is equal to a at t, is also